This is section 4.1, Introduction to Probability, basically. And it says Probability Basics. What do we have in probability? Of course, you all heard about probability from high school. You learned a little bit about probability and you forgot what that is. So the probability is just the chances for something to happen, something to occur. Okay, so what we do here, in probability, we run experiments, let's say. Maybe you want to flip a coin, you want to roll a die, you want to withdraw numbers from a box or a jar, and we are interested to know what are the chances that this number I'm choosing from the jar is going to be even. What are the chances that if I flip a coin is going to be head? What are the chances if I roll a die I will get number 5? And all these chances that I'm talking about, they fall under one thing called probability. So when I say what's the chance for something to happen, that's the probability. Okay, so that's a probability. That's what probability is. So in probability, what we do, especially in statistics, we run experiments. And what is an experiment? So by definition, experiment is any process with uncertain results. We don't know what the results are going to really be. Okay, uncertain results that can be repeated. So you can repeat the experiment as many times as you like, and the results of any single trial you do is not really known ahead of time. We don't know what this is going to give us, but the results of experiments over many and many trials, when you keep trying and trying and trying, then you might end up saying, oh wow, I'm noticing the majority of the outcomes of this experiment is giving me this thing or this thing. Again, this is statistic. There's nothing 100%. So that's why we run experiments. Now, when you run an experiment, you record all the results and collect them, right? Collect them. So when you record the results and collect them, that set that contains all the results is called a sample space. So the sample space, some people call it capital S, of a probability experiment of a probability experiment is basically the collection of all possible outcomes. All the results. And what else we need to know as definitions? Those are just introduction definitions. So we have also something called event. The event is any collection of outcomes. From where? From a probability experiment. So an event that we talk about event. That event may consist of one outcome, two outcomes, three outcomes. That's called an event. So flipping a coin, that's an event. Rolling a die is an event. Picking a number is an event. So in general, if we let E be any event, then what is the probability of E? The probability of E is defined as the number of favorable outcomes divided by the total number of outcomes. So how many are in favor to that event E? Event E means, oh, how many are going to be red, how many are going to be even numbers, how many are going to be heads, how many are going to be prime numbers. So those are called, that's how many, that's the number favorable to event E over the total number of outcomes. Let's look at an easy example to start with this. Say I want to roll a die once. Okay, the die, what's on the die? Die has how many faces? Do you remember? 6 faces. So you can label them as 1, 2, 3, 4, 5, and the one facing us 6. So 6 faces. So we can ask, what's the probability of rolling an even number? Well, how do I find the probability of rolling an even number? Well, you count how many of those 6 numbers that we have, 1, 2, 3, 4, 5, 6 are even. If you count them, the 2, the 4, and the 6, there are 3 of them over the 6. Don't forget to simplify this. Reduce by 3 is 1/2. So here, notice as the sample space is this 1, 2, 3, 4, 5, 6. The sample space is the one that contains all the possible outcomes. These are all the outcomes. And we were trying to find how many in favor to the event. In favor to the event means how many of these numbers are even. If you forgot, those are the even ones, 2, 4, and 6. 3 of these numbers are even, 3 out of the 6. So 1/2. Note here, this 1/2 that we got, this is an answer for a probability. It's a fraction. We can write it also as a percent, 50%. Or you can write it in decimal form, 0.05. So the 3 answers are all acceptable. So in MyMathLab, whatever my MATLAB says, you just follow it this way. If you got 1/2 and you key it in and it gives you something wrong, try the decimal or the percent. Now, all the probability, as another note, all the probability answers that we get, they must fall from 0 to 1. It can be more than 1, it can be less than 0. All the answers should be from 0 to 1. Now, another example here. Let's say we roll the die twice. Roll a die twice, this means, just think about it as if you're rolling 2 dice. Like that. So when you roll them, let's say at the same time, you're gonna look on the top. What do you see on the top? What numbers do you see? Maybe I see 3 here, maybe I see 2 there. So 3, 2, that's one possible outcome, right? 3, 2. Maybe you might see 1, 1, maybe 1, 7, not 1, 7, 1, 6. But now, how do we arrange all this? How do we organize all these? How many are there? What's the sample size or the sample space size? How many do we have? Well, watch how we do it. So on the first one, I'm going to use a table to make it easy. On the first die has these numbers. On the second die, 1, 2, 3, 4, 5, 6. These numbers. Let's construct the table. So what do we get for the first one? This is 1, 1, this is 1, 2. You read it, 1, 3, 1, 4, 1, 5, all the way to 1, 6. And here 6, 1, 6, 2, all the way to 6, 6. What's the total number of outcomes? Well, the total number of outcomes is 36. 6 times 6, right? 6 on the horizontal, 6 on the vertical. If you count them, there are 36 of them. That's the total number of outcomes. Now, how do we find probabilities? Let's say they ask us find the probability that the sum is what? Give me a number. Let's say 10. A sum of 10. No, this is what I do. I use the table. I know I'm gonna count how many. I know this is gonna be over 36. That's the total number of outcomes. How many of these numbers they're gonna add up to 10? Well, this is what we do. Which one adds up to 10? 1, 1 doesn't work. 1, 2 doesn't work. In the 1 row, nothing works. In the 2 row doesn't work. 3 doesn't work. 4 works. 4 and 6, right? 4 and 6, they add up to 10. 5 works. 6 4 works. Any more? No. Only 3 works. Only 3 numbers or 3 outcomes add up to 10. Don't leave the answer like this. We need to reduce it. Both are divisible by 3. If you divide each one by 3, that gives you 1, and you try this on the calculator, is 12. That's the probability. Now, what about if they ask us find the probability that the sum is prime? Sum is prime. What is that gonna be? Well, we have to count all the outcomes that are prime numbers. So recall, what are the prime numbers? So I'm gonna recall it here. Recall, the prime numbers starts at 2, not 1. 1 is not a prime. 2, 3, 5, 7, 11, 13, and then they keep going on and on. 17, 19, 23, etc. These are prime numbers. Are primes. So let's see how many gives me a sum of a prime number. I know it's going to be over 36. Let's go over which ones gives me a prime sum. Okay, let's look it up. 1 1 is 2. That's a prime sum. So I'm putting a check mark. 1 2 is 3. That's a prime. 1 3 is 4. 4 is not. 1 4 is 5. Is a prime. 1 5 is 6. Is not a prime. But 1 6 is 7. That's a prime. 2 1 is a prime. 2 2 4 no. 2 3 works. 2 4 doesn't work. 2 5 works. 2 6 doesn't work. 3 1 doesn't work. 3 2 works. 3 3 no. 3 4 yes. 3 5 3 no. 4 1. 4 2 no. 4 3 yes. 4 4 4 5 4 6 no. 5 1 5 2 5 3 5 4 5 5 5 6, and then 6 1 works. 6 2 doesn't work. 6 3 no. 6 4 6 5 works. Notice sometimes you see some patterns in the table. These check marks that I wrote down here, we got 6 along the main diagonal in the middle, and then there's 4 here, 10 and 13, 14, 15. So we have 15 possible outcomes or in favor to the event. And guess what? These are both divisible by 3. Question, yes?
Professor, when did we learn the concept of a prime?
Prime numbers, we introduced them back in 4th grade, and then we apply them in 5th, 6th grade, and we move on with them. Those are prime numbers. So prime numbers are the numbers that are divisible by themselves and 1 only. So 2 is a prime because it's only divisible by 2 and 1. 4 is not a prime. 4 is not. Why? Because since it is divisible by 2. You know what divisible means, right? Divisible means it has no remainder.
Oh, I see what you mean. Okay.
So 5 only is divisible by 1 and 5. 6 is not a prime because it's divisible by 1 and 6, but also divisible by 2 and 3.
I see. All right, thank you.
Yeah, those are called prime numbers. Now, the next example on the same problem, find the probability that the sum is equal to 13. What would be the probability here? We know it's out of 36. How many? If we look back at the table and try to find 2 numbers that sum 13. Well, the largest sum I can find 6 plus 6, which is 12. Oh, it doesn't work out. I can't find any of them, so I put 0. So what does that mean? 0 over any number is 0. This is called impossible event. Impossible event. In general, if the probability of any event E is 0, then E is called impossible event. If the probability is 1, 1 means 100%, then E is called a certain event. A certain event means you are like 100% sure you are going to pass the class. So you are really sure, you are certain that you're going to pass this class. Other examples about the coin examples. When you flip the coin once, flip any fair coin once. What are the outcomes? What do we get? You are gonna either get heads or tails. There's no other option. So the two outcomes. Okay, some people write like this, H comma T. Two outcomes. If you flip it twice or two coins, you can get head on the first one, head on the second, or you can get head on the first, tail on the second, tail head, or tail tail. What about 3 times? On the homework there's one to deal with 3 times. 3 times head, and I'm gonna do it in a vertical way. Head, tail, tail, head, tail, head. Tail, 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 head, tail, tail, head, tail, head. Do you see how I'm moving it around? No. Last one, we move the head to the left. Tail, tail. If you count, there's 8 of them. In general, why we get 2 only? If you flip it once, the total number of outcomes is 2 to the first power. That's where we get 2. Here we got 2 times 2 squared, 4 outcomes. 1, 2, 3, 4 outcomes. Here 2 to the third, because we did it 3 times. It's 8, not 6, 8. That's why you got 8 outcomes. How do you ask a question about this? How they ask us? So let's say a coin is flipped 3 times. Flipped 3 times. We need to find the probability. Part 1, let's say, the probability of getting 2 heads. Okay, 2 heads. Well, let's look at this list. We know the total is 8. Getting exactly 2 heads, where are they? 2 heads. 1, 2, 3 of them. Do you see that? So 3 of them. That's 3 heads. 2 heads. So the probability is 3 out of 8. Find the probability of obtaining at most, this can be, I can make it tricky, at most 2 tails. So what does that mean, at most 2 tails? Well, it could be, this means they ask us to find the probability of getting 2 tails, or what? If it's at most, means you can go up to 2 tails, or it could be 1 tail, right? Or, that's the tricky part about it, no tails, like 0 tails. So this means we need to count how many they have 2 tails, how many they have 1 tail, and how many no tails. Let's count them up. 2 tails, let's start with 2 tails, and I'm gonna circle them. 2 tails, 2 tails, 2 tails. Then 1 tail. Which one has 1 tail? This one, and this one. How many have 0 tails? 0 tails means all heads, the first one. So how many did I circle? Well, 7 of them. See, I circled 7. So that would be 7 out of 8. Another thing, let's say we have, as another example, no tails, no heads, no coins, no cubes. Let's say you have any number x here, and let's call this 1, 2, 3, 4, getting a number in there. And then, you know, we ask people to withdraw. We put these numbers 1, 2, 3, 4, 5 on piece of paper many times, and we put them in a jar, and we ask a lot of people to withdraw these numbers, and we start recording, you know, how many people got this, how many people picked up the number 1. Let's say 8 people. Let's say here 9 people picked this one. Let's say 12 here, 2 there, 4 here. Okay, that's the number of people who selected this number. Then we can ask a question, find the probability that I'm gonna do all of them. Find the probability of someone selected number 2. What's the probability of someone selected number 2? Well, you're gonna go to number 2. This is number 2 here. If we need to find the probability of someone selected number 2, you ask yourself, how many people selected number 2? How many are in favor to the event? Well, we have 9 of them. Now, what's the total number? What's the total number? Total number of people. It's here. We add them up. 8 plus 9 plus 12 plus 2 and 4. What is that going to be? This is 17. This is 12, 14, 18. 18 plus 17, 35. So we got 35. 9 or 35. And it can be reduced. So that's the probability of getting 2. What about if they ask us to find the probability of getting of x more than or equal to 3? Like, what's the probability that people got 3 or more? Well, let's see. Total is 35 again. How many people selected 3 or more? This is 3 here. 3. So 3, it will give us how many in the 3? There's 12. In the 4, 2. And in the 5, 4. So we add them up. 12 plus 2 plus 4. So that gives me 4, 14, 18. 18 over 35. Not reducible. What about if they say find the probability of x less than 2? Just less than 2. What is less than 2? Well, I look at a table. Less than 2 means the 1. That's what they mean. So it's how many in the 1 divided by the total. Any questions about this? Now, when we run any experiment, you know, about any thing that we have to make sure. Sometimes they ask you, let's say they give you a table, they ask you, is this model a probability model? Let's say, you know, someone is picking, choosing a color. Let's come up with colors. Red, green, blue, brown, yellow, and orange. And this is the probability here. Say it's 0.1, 0.1, 0.1, 0.4, 0.2, 0.3. Is this a probability model? Well, what does it mean, probability model? It has to satisfy 2 conditions. One, all these probability answers in the second column, they all have to fall between 0 and 1 inclusive. Are they? Yes, the probability of all the colors, they all fall between 0 and 1. That's satisfied. And the next condition is the sum of all these probabilities they should add up to 1. Well, let's see. Can we add them up? Let's see if it's 1. 0.1, 0.1, 0.4, 0.2, 0.3. So let's see. What does that give us? 0.7, 0.9, 0.10. Oh, that's 1.2. It's not 1. So it's not a probability model. Why they have to add up to 1? Because 1 means 100%. 100%. So I can change in the problem, let's say, and I want to make this 0.2. Then that becomes a probability model. Do you see that? That becomes a probability model because all the probabilities are going to add up to 1. Right? So that's what it is. The next thing is we can ask as a question, which of the following numbers could be the probability of an event? Which one of these could be a probability? Let's say 0, 0.001, 0.35, negative 0.4, 1, 1.4. This can be a standard question to ask. Well, can the probability be 0? Yes, we said it's 0 to 1. Yes, yes, no, yes, no. So it has to be any probability. The answer has to go from exactly 0 to exactly 1. Any questions about this? That was like the introduction to probabilities. What is a probability? Now this part here that you see a pair of dice, this is the same one as I drew on the table, just in case. This is 1 1, this is 2 1. Do you see the dots in there? That's 2. That's 3 1, 4 1, 5 1, 6 1, and then 1 2 and so on. But instead of drawing this way, I put it on this table here. So that's the same thing. And here they talk about the probabilities that has to be between 0 and 1 inclusive, impossible event, and certain events. That's what this is about. And this is the main definition of a probability. What is a probability about? Any questions about this?